Our session today will be on linear regression. A linear regression is mainly about relationships. These relationships that exist between two variables. The variables we call the dependent variables, and the variables we call the independent variables. So by the time we're done with this, we need to learn how to develop basic concepts of linear regression from a probabilistic framework. You should also be able to use the regression equation to estimate parameters in hypothesis testing with linear models, and also how to actually set up a linear regression equation. So what is linear regression actually used for? This is a technique that is used for modeling analysis of numerical data. Using a regression equation, you're able to establish the relationship between two variables, which is called linear regression, or more than two variables, which is called multi-regression. We're also able to use the regression equation to predict future trends. For instance, you want to come up with a sales budget for the next quarter. You can use the linear regression equation to approximate how much sales do I expect if I pump in so much. It's actually for forecasting purposes. Regression is also used for estimation. It will give you an interval within which you could have a certain range of values, especially if your regression is very stable. Regression is also used for hypothesis testing and for modeling causal relationship. For your research, causality is going to be very important. As you come up with research topics, if you want to measure the relationship between two variables, for instance, the relationship between the work experience and output. Why is that? Usually most human resource practitioners want one individual who has had larger experiences. So you could come up with a topic, but you need to use a regression model. So regression model is epitomized by this regression graph. So we have what we call the dependent variable, which is y, and the independent variables, which are x. So the dependent variables are actually your outcome. The independent variables are actually your predictors. These are the values that make y. So your response variable is actually your y, your explanatory variable is actually your x. So it will be imperative for you to identify which one is your response and which one is your explanatory variables. For instance, we're dealing with an equation between advertising and sales. From your own basic knowledge, which one do you think is your dependent variable and which one is your independent variable? Between advertising, which one depends on the other? Advertising and sales. Which one depends on the other?
I think sales depend on the advertising.
Good.
Wow.
So meaning our sales will be on the y, they're the dependent. The independent are what? Advertising. So the examiner sometimes will swap x and y, or not put any x and y, but will swap them. So I need you to really know which one is your dependent and which one is your independent variable. So this A here stands for the y-intercept. We call it a cutting point. Any intercept is called a cutting point. This is a point where when x is 0, what is y? For instance, if this was our advertising budget, at 10, these are the sales that we're going to make, whether we have advertised or not. The 0.2 is our slope or the gradient. This determines the percentage increase of x reflecting on y. For instance, for every $1 1/4 increase, in your advertising budget, 20% will be attributed on the sales. So this is what advertising can be related to this equation. So understanding the basic elements of this regression equation. So why do we use a linear regression? Typically, we would want to see how the values of x affect the y. So linear regression sometimes can be given by the
Sorry to
equation.
cut in. I have a question.
Yes, please.
It's not really about this, but I just want to find out. Linear regression is after the topic of probability. It's my first time joining, so
it's
I
an
just want
independent topic. So these topics are not dependent on. Regression is about relationships. So regression really gives you a picture of how the values of x and y are related. So this regression equation looks at a positive relationship because it's upsloping. So to ascertain whether it's a positive relationship or a negative relationship, we use what is called R. R is called the coefficient of determination of correlation. So the coefficient of correlation simply gives you the direction of your graph, whether it is what? Negative or positive. So if you get R is 0.903, just get the sign there. It means that x and y are positively related. If your R is negative 0.903, it means you have what? A negative relationship. Then we have what is called R squared. You're just squaring the answer you get. That is called the coefficient of determination. The coefficient of determination simply gives you to what extent y is affected by x. For instance, if your R squared is 0.816, it means 81.6% of y is as a result of x. It also tells you to what extent these graphs are related. Are they strong or weak? If the dots are close like this, it means you have a strong relationship. So if your R, for instance, more than 50%, strong. If it's between 20 and 30, it's moderate. It's below 20, it's weak. So sometimes the dots can be away from this regression line, means you are less than 50% or less than 20%. It's a weak relationship. So this is a negative relationship. Why? Because our correlation coefficient is negative. But you could have a strong negative relationship when your R squared is greater than 50%. Then you can have a negative and weak relationship if your R squared is less than 50%. So what we use is called the coefficient of determination. And the regression equation is given by y is equal to a plus bx, where a is called the y-intercept and the b is called the slope. The formulas that you need to know are only 8. Number one, we say that the regression equation is given by y is equal to a plus bx. For where a is a y-intercept and the b is the slope. So this one is given by summation of x, summation of y over n minus b summation of x over n. Then y can only be found after we find our a and b. So how do you find the slope? Summation of xy over summation of xx. Then we go to R, which stands for the coefficient of correlation. Coefficient of correlation simply gives us, what does the coefficient of correlation give us? Can somebody explain? So coefficient of correlation is given by the formula R, which is given by summation of xy over square root of summation of xx times summation of yy. And our R squared is simply when we multiply R times R. That's all. Now the question is, what are these xx and yy? These are called the variations in x. So summation of xx, just put an array of x's. Summation of x squared minus summation of x to the power 2. Then summation of yy is equal to summation of y squared minus summation of y to the power 2 over n. And finally, summation of xy, just xy is throughout. Summation of xy here minus summation of x and summation of y over n. These formulas must be part of you. They're easy. Once you get these formulas, then you're good to go. So now we're going to do a question together. Suppose we're given values of x and values of y. I'll just give a simple example here. 1, 2, 3, 4, and 5. You are given 1, 1, 2, 2, and 4. So the first question is, we're asked to plot and comment. Okay. So this one, most of you know how to plot. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here I have 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 1, 1. So put our 1, 1 here. 2, 1, 2, 1 here. 3, 1, 3, 2, 3, 2, put it there. And 4, 2, and 5, 4. So you can see this is a what? What comment do we have? It's upsloping. And it's positive. And here, this is what we call a scatter diagram. Scatter diagram. So you get your 5 marks for this. Any questions so far on plotting? Anyone behind? Are we together?
Yes, we're together.
And now we go to coming up with the regression equation. So to come up with a regression equation, we need to fill in this We have xy here, x squared here, have y squared there. All right. So here we have 1, 2, 3, 4, 5. Here we have 1, 1, 2, 2, and 4. Help me get the figures in here. What figures do we get?
First one is 1. One, 2, 6, 8, 20.
Please continue.
9,
We're squaring this.
16.
Anyone lost
Yes.
what we're doing? 5 times 5?
25.
25. Then here it's y squared. We are squaring y. 1 times 1, 1. 1 times 1, 1. 2 times 2, 4. 2 times 2, 4. 4 times 4, 16. Okay. So let's total up here. The sum of x is the total here. This E means sum. Sum of y, sum of xy, sum of x squared, and sum of y squared. And our n is the number of pairs we have there. What is our n? 5. Quickly, what totals are we getting?
The first one is 15.
15,
11.
are you sure?
10.
10.
10 here,
37. Huh?
37 here,
10 there.
here,
55.
55 here,
26.
26, correct. So now the ladies, since we found everything here, the ladies find the sum of xx, the gents find the sum of yy, and collectively you find the sum of xy. These have your calculators nearby. Looks easy when somebody's solving. Once you find these preliminary calculations, then the rest is very easy. Quickly find these answers.
What is S?
Sum of square xx, sum of square yy, sum of square xy.
Oh, okay.
So solve them. N is what? Please calculate. In fact, do all of them. Confirm the answers. Let's get busy. X6. yy, and xy. Quickly give me the figures. I'm giving you 2 minutes. Find all of them. Everything is there. So if you've done your calculations right, these are the answers you should get. X, 10, YY, 6, and XY is 7. So these are just preliminary calculations. Now we need to find our B. Our B, before we go there, our XX was what? XX was 10.
10.
YY was 6. And our XY was 7. Now find the B. The formula was XY over XX. To find our A, it was summation of Y over N minus summation B, summation of X over N, and our R was summation of XY over XX. And our R squared was just multiplying R times R. Our summation of X was 15. Our summation of Y, we had found our summation of Y was 10. Our N was 5. So with the given parameters, I will also give you a chance to calculate these figures. Please, everything has been given to you, just an issue of substituting. So can we go ahead? To start with, what is B called? B is the slope, right, of the gradient. So lead me through. What is XY? What is our XY?
XY is 7.
And our what? XX?
Our XX is 10.
So what do we get as our B? Quickly, team members.
7.
0.7.
0.7.
Team, our A is called what? A is called what?
Y-intercept.
Y-intercept. So how do we find it? What are the figures we have? (10 over 5 minus
0.7.
the slope we found 0.7. Then summation of X 15 over what?
Edina, are you there?
2 minus 0.7. And what is 15 over 5?
Okay, thank you. Edin, sorry. Abigail, are you there?
3. So what do we get? Our A will be 2 minus 2.1. So our A is negative 0.1. So we know that our regression equation is given by what? Y is equal to A plus BX. So since we have our A, we're going to substitute what we found on our A. What was our A? Negative 0.1. And what we found on B? What did we find on B? Found on B
0.7.
0.7. Then you leave out the x as it is, because this is now an equation. So just substitute your A and your B to find the regression equation. So this is our regression equation. R stands for the what? Coefficient of
Correlation.
correlation. What does it give you? It determines whether the relationship of x and y are negative or positive. So what is our x? What are we getting as our xy?
Our XY was 7.
37.
I'm in class.
So the formula was xy over square root of x times yy. So what was our xx? Was 10. And what was our xy? Our yy was what? 6. So this is 7
Yes.
over the square root of 60. Will give you 0.903. So your comment would be the positive relationship. Then R squared is a coefficient of determination. You're simply multiplying 0.903, or you're squaring it. This will give you 0.816. So what does this mean? It means that 81.6% of y is affected by x. Okay, that's what it means. It means 81.6% of y is affected by x. Any questions? Right, so they'll also ask you, predict y when x is 10. This is our regression equation we found as negative 0.1 plus 0.7y. So they'll ask you, find y if x is 10. So where there is y, where there is x, we put what? A 10. So 0.7. So here we put a 10 there. That's the other row that regression does. It helps you find what the other is when you substitute. So meaning our y will be 6.9. So quickly, what did we do? We're given an equation like this. X and y, we asked to plot a scatter diagram using an x or y plane. Make sure you label the parts, our y and our x. Y stands for the dependent and x for the independent. You plot them as they are. This is called a scatter plot or scatter diagram. Secondly, they'll ask you to find the slope. Let's fill in this table, values of x and y. When you multiply them, find xy. When you square each of them, you find x squared and y squared, and you total up. Then once you find these totals, you find the sum of xx, yy, and xy using those formulas there. Our xx is 10, 6, and 7 respectively for yy and xy. These are key for you to calculate the slope and the R and R squared. So our slope is xy over xx, 7 over 10, 0.7. You can only find the A after you find the slope, because in the formula for A, which is the y-intercept, we have summation of y over n minus b summation of x over n. Our n, remember, is our sample size of the pairs. So here 10 over 5 minus 0.7, 15 over 5, which gave us 0.1 negative. You substitute in the formula here where there's A and B, negative 0.1 and positive 0.7. When you substitute, you're going to find the regression equation. By the way, the regression equation sometimes is written by B0 plus B1 x, where B0 is the same as A, B1 is the same as the actual B. Any questions at this point before I proceed? Any questions? Any questions so far? Please ask.
Collins, kindly repeat this again. That's this part. Thank you.
Okay, so I'll say the regression equation is given by A plus y is equal to A plus bx. Our A is the y-intercept. Some books will not use A, they use this equation, so don't get confused. So the equation they'll use is B0, which is the y-intercept, and B1 is what we call our B. So it's the same thing. All right, together, our B1 is the intercept. Are we together?
Yes, thank you.
So B0 is the y-intercept and B1 is the gradient. So this is for a multiple regression equation. So I've already explained much of what you need to know. But when you're given an equation like this one here, 7.5 stands for the autonomous part, or the values that don't get affected by the gradient. 0.5 here, it will tell you that unexpected change in height by an extra unit with what? 50% or 0.5. That is how we explain the 0.5. So I'll give you, based on what I have explained, I'll send this on the group so that you can go through. The next class I'll talk about will be on analysis of variance. And I want to leave you with some small work on this. Then we'll continue our session with estimation and sampling. So I'll send some work on the group just now. Unless there are any questions from what we have discussed.
You're going to share the recording. A bit behind, I joined in late.
All right, I'll share the recording.